Morning, guys. You may turn on the camera, and we will start the lesson right away. Now I'm now taking attendance. I find 譚俊傑。All right. Okay, all of you here.
天上今日生日咯。
係啊。做咩啊？最衰返唔到學啊！ if so, I can see you guys, right? But don't worry. Next week we will see each other face to face today. All right. So, now even though I'm not a big person here in the world, so I still need to work. So you too. Today, you will see me here to have your lesson. And today I would like to talk to you about the long questions. Now, something I need to tell you on the questions. Now, for the first 4 questions in your chapter exercise, which is in page 27, please take a look. Question 14, 15, 16, and 17. For those 4 questions, I have just introduced it in Chem 1 video, okay, in the Chem 1 lesson. So today I would focus on the other 4 questions, okay, such that you guys can cross-check each other and go back to the video of the other class, okay? Can you get my point? Such that you finally have covered all the questions. Do you understand? So I do think it's the advantage of having online lesson together with YouTube videos, in which you can also can learn outside the lesson hours, learn at your own pace, for to get to know more about the questions. Now, question. Could you please take a look on page 29? It is on question 18, where we try to have a further look on this question. Question 18. Now take a look. And our focus for today is to cover those questions. Okay, something about experimental method. Okay, in the next lesson, we will go over with you on collision theory, which is next chapter, and you need to get to know some of the explanation part. It's very, very important. And this one is just focused on the methodology. Now, so don't worry about even though you for some questions in which you don't find it so familiar with you, don't worry. What you focus on is to keep calm and try to take a look. Any change in physical property can be recognized, and use this as a start, and you think of appropriate the experimental method to monitor the progress of the reaction. Now, question 18, take a look. Now, even though you don't know this chemical, so we call that peroxyl disulfate. The first change name, isn't it, right? Peroxyl disulfate is made by electrolysis of saturated solution of potassium hydrogen sulfate. So hydrogen sulfate, it is KHSO4. While for peroxyl disulfate, we have got the formula H2OH 2 minus. Okay, all of you, please mark it down. H2OH2 minus. Why we call that peroxyl? Per means a high, over we mean per high power, right? Oxyl means oxygen. Okay, disulfate, which means we have got 2 sulfates. They're connected together. So it is a very powerful oxidizing agent. All of you, please mark it down. Oxidizing agent. So which can undergo some redox reaction, okay, with some other chemicals, including this. So you may find peroxyl disulfate ions react with iodide to form sulfate and IOD. Now you may check on the web, and you may soon realize that peroxyl disulfate is colorless. Iodide is also colorless. Sulfate is colorless. How about iodine solution? Iodine solution, what is the color? Just like last lesson, I keep on asking this question. What is that color? What is the color?
Yes.
Iodine solution. What is the color of iodine solution?
Purple.
Purple. Purple. Agree? Purple. How about the others? You agree? Parker, do you know the color of iodine solution? Then you may see the word aqueous, AQ. So it is in mainly water as a medium, right? You know the color of iodine solution?
Yellowish brown.
Yellowish brown, yes, correct. Now, it may be confusing to some of you. So for iodine in organic solvent, I will say it as purple. So as iodine vapor, purple. Iodine solution, it is brown or yellow depending on concentration. For low concentration, it is yellow. Like high concentration, brown. But for mainly for that, you may find iodine solid being black. Now, so you may find all those colors are very interesting facts about iodine in different states. And second, it's about iodine. You know, the iodine is a molecule in which it doesn't dissolve in water so well. So how can we prepare iodine solution? Do you realize in our chemistry lab, for that brown solution, it is always described with this, I2 in Ki. What's mean by that? I dissolve iodine in potassium iodide solution. So it is a very special way to prepare iodine's aqueous solution. Okay, what is the hidden message? Iodine much dissolved in iodide, but not aqueous, but not water. But iodide solution is aqueous. So what will be formed? We have got that stable form of iodine. We call it triiodide ion. And in which this is the stable form. It is a very stable form of having a solution, and it is also an ion responsible for the brown color of a solution. So they start from this. Now, don't worry, even though you don't know the details of something about iodine, but you still need to know the color of the iodine solution, because next questions they will ask you. Now, you're going to keep track of the change in the concentration of iodine by measuring the absorbance, the change in the absorbance of the solution mixture over time. So my question is that explain why the colorimeter could be used in these experiments. So you need to mention those questions about, right? All those things about. So first of all, you are going to tell me iodine solution, it is brown in color. So as the reaction proceeds, what will happen about the color change? What is the color change? The reaction mixture turns or changes from colorless to brown. So due to, you know that brown, it is due to the iodine formed. Okay, so density of brown iodine solution is monitored by what? Measuring the absorbance of the brown solution mixture over time. So what is the principle behind? It is based on Beer's law. Do you still remember? It tells you the absorbance. It is directly proportional to the concentration of colored solution. In this case, we are now referring to iodine. So if you keep track of the change in absorbance, which means that iodine concentration would have got a change. Can you get my point? So this it is a supplementary part, third explanation part to these two sentences. You may find that Mr. Chin about the question, or there is such a discussion. But what is the relationship between the two? Concentration of iodine and absorbance, right? That two, they are in direct proportion. So which means that the darker the brown solution, which means that the more light will be absorbed by the solution. So if I use this data as a start, and you will you may project it back to what is the corresponding iodine concentration at that moment. Do you understand? So this is what you know about the use of calorimeter. Okay, it is used. It is an instrument for you to quantitatively know how dark the solution it is. Because I know that if I correspond to that certain darkness of solution, it tells you how concentrated it is. So we first of all we prepare all those data, and later on I just directly measured absorbance. Can you get my point? Now the question comes, Mr. Chin, how can I project the absorbance to concentration about from this graph? How can it be done in practice? Anyone who know how can it be done in practice? I know the absorbance data. So what is the next step? How can we project it back to concentration? So I know it is in direct proportion, but I don't know whether what is the ratio? What is the ratio, right? So what should be done next? You know it. What should be done next? Yao Xing, do you know what should be done next? Once for the calorimeter, what I just got is absorbance. How can we go back to concentration? Do you understand the questions, right? You know what is it about, right? So the absorbance will tell you a degree of how dark the color is, right? But do I have anything to help you relate that darkness of the brown solution with the corresponding concentration? Now that one,
the darker the solution, the higher the concentration.
Yes, the darker the solution, the higher the concentration. But the question is the quantitative way of comparison. How dark the color of the solution? They will tell you what is that exact concentration. Can you get the question, right? It is rather problematic. It's not just qualitative comparison, but also the quantitative way to take a look. Anyone who have a habit of keeping fish at home? Anyone who has got a fish tank? No. Anyone from Pickup here in this group? Who? No. Now, do you know that we have got just imagine some cases in which, for example, if I really want to know how acidic or how alkaline the solution, I would use a pH paper, right? But based on the pH paper, how will you know? How will you go back to the pH of the solution? I need something. I need one more tools. Okay, which is color chart, right? So you maybe some of you, you may find that Mr. Chin, in case I have got the color chart, I can solve everything. Now, what's the meaning behind? Now, for example, now if you search on the web about water, the nitrites, for example, the nitrite content in water, so you may find some kit, so testing kit, for example. Now, so you may have such idea in mind. Now, for example, if I have got a kit like this, in order to keep track of certain chemical concentration, for example, nitrite. Now, in fresh water, why do we mention much about nitrite? Is that nitrite is toxic to water lives. Okay, highly toxic. While the nitrite comes from where? Do you know? Something about biology. You study biology, right?
Yes.
Where do the nitrite come from?
Come from the
Think of something basic. While the fish always does every day, and you may know. What do fish always do in their lives daily? Just like you.
they
I see.
They excrete so that there's
right.
nitrite in it.
It's not, besides eating, you need to do something else, right? So yes, that's right. So as something is nitrogen containing, we release into water. But of course, first of all, it's not nitrite. It is something organic substances containing nitrogen, and later on that compound will decompose, okay, to form some other thing else. The first thing that will be decomposed is ammonia, okay, NH3, and then later on the ammonia will return to nitrite. Now both ammonia, NH3, and nitrite, NO2 minus, they are toxic. Okay, so that will affect the lives of the fish there. So people would use the testing kit for help, right, to keep track of how toxic the water is, so as to do some immediate action. For example, I would change some part of water from the tank, and I replace it with a new water. Can you get the point? So this is the color chart they will commonly use. Now, of course, do you mean that nitrite it will have a color? No. So the testing kit, the way to do the testing kit is should be having a sample of solution, and I drop some other chemical and shake it and let them change its color. Can you get my point? In order to show how toxic the solution is by telling you how dark the color is. So what should be done next is to have a color chart and measure it one by one. Now, for example, I found the solution being pink. So how pink it is? If I know how pink it is, I measure the color, I know what is the concentration. Do you know the tricks, right? But of course, this one, it is rather problematic because it will give you some error, especially human error. Now, different humans, they will have different judgment, even though you'll be given a pink solution. Now, somebody will treat it as 0.5, or some will treat it as 2.0. How about in between? Now, it's quite hard to judge, isn't it? Now, if in case it's not the second pink, but the pink is just an in between, so how will you know the answer? So besides using color chart, I will use something else. We will use the term calibration curve. Do you know it in biology? Calibration curve, 校準圖表. Calibration curve. So what is that calibration curve be like? So we have got absorbance and the concentration of iodine solution. Try to get to know the mathematical relationship between the two. So how can it be done is that you are going to prepare some tubes of iodine solution of the accurately known concentration. Okay, just like this, you're going to prepare some tubes, for example, 4 tubes. So the 4 tubes, they are of different color. For example, it's very dark, less dark, like this. Okay, and once you have got that 4 different colored tube, so you're going to put it into the calorimeter and directly measure its absorbance. So what should be expected to show? For example, you got it at the 0.1, 0.2, 0.3, and 0.4 for tube 1. So we will get the result like this way. Tube 2, this. Tube 3, this. Tube 4, this. 1, 2, 3, 4. Can you get the point? The darker the color of the solution, the higher absorbance it must be, right? So you may get this. So you think of tube 5 to 6 to 7 or in between 1 and 2. So what we expect? Altogether, they would lie on a hidden straight line. Can you get my point? A hidden straight line. So what you're going to do is to plot a graph with a straight line passing through origin 0. Of course, it must pass through origin 0. What does it tell? If the iodine concentration is 0, which means that no light will be absorbed, it does make sense that water, for example, distilled water, the ionized water is colorless. Of course, they will not absorb the light of that frequency. Can you get the point? So what tricks are you going to have? You are going to have a calibration curve and use this as a start in case you measure the absorbance. Now, so go back to the design of experiment. So you are going to measure the absorbance at different time, okay? Which means that, for example, we've got from 0, 10, 20, 30 seconds, right? The absorbance, there will be something as 1.0, 0.9, 0.8, etc. Right? So you may continue the data. So afterwards, you can use this data as a start, and you can project this data to record to the corresponding concentration of iodine solution. Now, by doing so, what will be got finally? So you may get a graph like this: iodine concentration versus time, right? So it is also agreed with this graph, absorbance versus time. The shape of them, they are more or less similar, right? Can you get my point? So first of all, your graph, they will show you this, and then later on, you show you this. I need to change from absorbance to iodine, right? So you use this graph for help. Calibration curve. 校準圖表, you know, do you understand what I mean? So for this calibration curve, it seems like color chart. Okay, with the number, you're going to check, right? So don't use this one. I use this. Can you get the point? By doing so, you can quantitatively get to know more about the relationship between them. Do you understand? Do you understand? You got it? Now, how about B part? Suggest how the initial rate of formation of iodine can be determined from a concentration time graph. Here, suppose you have got this. How would you, so sorry, my fault. This time iodine, it is just reverse. Because iodine, it is in the product, okay? So the graph should never behave like this way. Instead, it's quite the opposite. During the whole progress of reaction, iodine, because it is in a reactant, or the graph should be, what should it be? Anyone who can help? Quite the opposite. The graph, they will show it like this way. Do you understand? It show it like this way. Now, so this is what we would need to highly aware, right? Iodine, where is it? If it's product, the graph will be this. Okay, if it is reactant, they will slope it down. So both, it's not just reactant, but also the product can also be used this method as long as there is a color change. Now go back to your textbook. Is on page 17. Page 17. So you may find the similar graph, okay? But this is in downward slope. Why? Because the iodine is now consuming. But for our case, it is iodine being produced. So the graph should be looking something like this. But of course, the data is not correct also, right? I predicted wrongly. It's not like that. It should be something like this. It's a 0, and then with 0 point something, and the data will become increased, right? Do you understand? The fastest slope, the fastest curve they found at the beginning, and while it decreases, and finally it level off, so it becomes a flat. The graph becomes flat. Now go back to this. Suppose you'll be given this graph. How would you suggest how you see that? How would you determine the initial rate of formation of iodine from the graph? Descriptively, using words, tell me how. Now this sentence you must memorize. They will test it very often. 成日問㗎啦呢句，嗱記住係答聲啊，成日問㗎 ，always ask。翟家興。
係咪畫條即係喺零嗰度畫條 slope 上去？
畫條 slope. So what is that? That line, right? How will you call that line? We call it a slope. Should we call it a slope?
No. A slope of tangent to curve at 0 seconds.
Yeah, good. So this is what we call it as a tangent. Okay, the tangent to the curve. And then use this as a start, and you are going to find out the slope of tangent at certain time. This time because you talk about initial rate. So the timing should be time is equal to 0. So it is the by determining slope of the tangent at time is equal to 0, you are going to get to know the initial rate of formation of iodine. Can you get a point? So how you say that descriptively? So first of all, draw a tangent at time t is equal to 0, and then determine its slope. So that is the answer. Do you understand? So this suggests how you talk about steps, experimental steps. So what is the first step? Draw a tangent. At time is equal to 0. Number 2, and determine the slope of the tangent at time equals 0, and you may find the initial rate. Do you understand? Okay. Questions? Do you find it difficult? A bit? How about question 19? Have you followed? Shall we move on to question 9? Any questions so far? If you've got a questions, let me know now. Any questions? Any questions? You understand? Okay, so shall we move on? Now, on question 19. Now, question 19, it is another set of experiment. Even though you're not so familiar with it, don't worry. It is the questions related to the change in what? Change in what? Cloudiness of the reaction mixture. How we know the solution become more cloudy? Can you see the word? Precipitate. So you are going to keep track of how much amount of precipitate is formed over time. Okay, so first of all, please underline the chemicals to be used. It is made by the reaction between sodium thiosulfate and dilute hydrochloric acid. So the first question, they will directly ask you the equation. The equation. Here it A part. So what is the equation between the sodium thiosulfate and dilute hydrochloric acid? You may refer to the textbook as well, okay? Take a look on the previous pages. We have got this. Here it. Mr. White, tell the equation. Yes, please locate for me the equation. Where? Sodium thiosulfate and dilute hydrochloric acid. Now, all those equations that appear in this chapter, you better memorize it, huh? You better memorize it.
Okay.
First of all, search for the equation in the book, where you find it. Chen Yingzhen, you know which page? You talk about the cloudiness, changing cloudiness of the solution. Chen Yingzhen, you find it?
Is it page 17?
Page 17. 17. Sodium thiosulfate. Where you get the sodium thiosulfate?
Oh,
Now,
18.
18. Good. 18. You may find it, right? So that is the equation. So sodium thiosulfate, S2O3 AQ. Now this one, S2O3 2 minus. Now this is the anion. You need to memorize, and together with HCl to form sodium chloride AQ, SO2 gas, sulfur, and H2O. So remember to balance the equation. You may also write down the Ionic equation as well. Anyone who can tell the Ionic equations? The chemical, the Ionic equation.
SO3 full. And add
This one, no, not SO3.
so S2O3 full.
Yes.
Add 2H plus.
Yep.
To form SO2.
Yep.
Add solid.
Yep.
Add H2O.
Thank you. Now, very good. This is the Ionic equation. Now, both Ionic and full equation will be accepted. So you may find it is mainly the chemical reaction between the thiosulfate ion and hydrogen ion. That two ions that meets to collide together to form sulfur. Well, you are going to keep track of how much sulfur is formed during over time. Okay. So you may find which forms of precipitate identify the product. I've spoken. This is sulfur. This sulfur. I don't know why is it so strange, right, for me, because it seems like this one. There's some problems about this, right? So this is what the sulfur, the form to precipitate, it is sulfur. So as said before, an equation. Now this is the Ionic equation. Now, so for the full chemical equation, you may find it in the book, page 18. Okay, you may get the answer for ionic, the full equation. For ionic, I show it here. So it's sulfur, which is responsible for the cloudiness of the reaction. So we are provided with some common apparatus describe how you measure the time taken for the small fixed amount of precipitate form. Draw a label diagram experiment that you will use. Again, you can also find this in the questions. Where? Page where? Which page? Leung Kun, you tell me where you find the page.
Hey, hi. Let me see. Uh, 19.
Yes, 19. So now, if you write down, draw a label diagram, you are going to refer to page 19. How about this? Describe how, because you are going to tell the experimental steps. So you are going to refer to page 18. Okay, so you just copy them or you can get the marks. So it is something, a reminder about the answering technique. Describe how. Whatever you see this word, describe how, which means that you are going to give me experimental steps. Step number 1 was that step number 2 first, secondly, and then finally, right? And then draw a label diagram. It is the graphical way to represent those words. Can you get my point? So you have got 2 instructions. Now, please take a look in the page 18 and 19 respectively. What is that? Now, please locate the content to be put in this question. So first of all, describe how. Of course, you are going to have this, right? With this step, this is the step. So you may find to place a sodium thiosulfate solution in the conical flask with a marked cross marked onto a piece of paper and put it above. And you're going to add the dilute hydrochloric acid of a certain volume, and at the same time you start to stop time at the stopwatch. You are going to look at the cross from the above and check. Now this is the key point. You are going to check the time. Now you may, if you really try to put it into the questions. This is the way to answer. Place this. Now and then use these wordings, and you may now solve. Record the time. When the marked cross is invisible, when this is the one way, or you will use the word when the macros is blotted out. Blotted out, which means totally covered by something. B-L-O-T-T-E-D, blotted out. It's covered by something. Covered by what? Covered by those water insoluble sulfur. So you need not mark, you need to put it like this, right? Okay. You directly put it here and you can get the answer. Now take a look on the graph next to it, page 19. So you may see it as a 3D diagram, but to you, you please draw a 2D. Okay, so how will you draw a 2D? Quite difficult, isn't it? Especially for the cross, right? It's unavoidable to draw a cross in which it seems like it's a 3D shape, right? So the graph that you may see is something similar to this, right? The macros put it just above a conical flask containing reaction mixture. I remember to put an I here and a timer, right, to tell me we are now doing something rate measurements involving the time taken for the macros to be blotted out, or macros becomes invisible to you when you view from above. Questions? So you are going to measure, once again, I need to tell you, you are going to measure the time for the cross to become invisible when viewed from about the flask, which means this, okay? View from above, view from above the flask. Do you understand? How about the part? The turbidity of the sewage reaction mixture increases when the reaction proceeds, which means the cloudiness, right? It become more cloudy. The amount of light can be passed through the reaction mixture get less, of course. Technicians study the chemical kinetics of this reaction by using a light sensor connected to the data logger interface and a computer like this. So you may refer to the page 30 again. You may refer to page 30 again. Now, page 30. Now, this is the graph. So this time, you are going to measure the transmittance. Okay, transmittance, which means that which means how much light can still pass through the solution. How you know the how much light, how the extent of the how light they can pass through the solution. It is measured by checking the intensity of the color here. It is called intensity of incident rate of incident light, and here you're going to compare with this one, okay? After passing through the light passing through the solution. Now, in case the solution is more cloudy, which means that there will be much light less to be detected here. Okay, so you may find the bigger difference it will use this data. You go back to the data logger interface and tell you this. So you may find this is the one. Of course, if you want to talk about transmittance over time, the graph of this must not be like this. It's problematic, right? The computer, the graph inside is misleading to you. In case I have got this transmittance over time, so what would you expect to be the shape? It's not like that. If I write like this, which means that the more light can pass through the solution. It's quite the opposite, isn't it? So the graph will show it a downward trend like this, right? Okay, you get the point. At the very beginning, because the two solution is colorless, so of course, all light can pass through theoretically, right? And then when time proceeds, what will happen? The more precipitate is formed, they'll block the light more, such that we will measure it as transmittance will be less. They will drop down. The more cloudy this is, the lower the transmittance. So we call it downward trend. But it's not a gradual decrease. You have a sharp decrease, and then the slope will become, the slope of the tangential graph will become less steep, and then finally they will level off like a flat curve. Can you get my point? It is because of a drop in concentration of the chemicals inside. Do you understand? Tell me the advantage of using data logger with a light sensor. Using this method, what is the good point? Good point about this.
Continuous measurement.
Yep, good continuous measurement. Because what you can get is we've got a continuous readings can be plotted, right? The light transmittance of the reaction mixture against time can be taken. Now, if you don't, or if you want to mention, it's not just readings. We want to get a graph. So you write a graph. I change the word taken to the plotted, right? Can you get my point? Of course, we are lazy, right? In case I want to have a computer, instead of giving you so many data, I don't want the data. I want to give me a shape of the graph to tell me the progress of reaction from picture. So I use a graphical way. Can you get the point? So can we get both on the computer interface? The answer is yes. You can have both, but to us, most of the time we will not study that data in detail. Right? You want to know the whole progress of reaction. You use the graph for help. What else? You can think more, right? But this is the part. What is said is to be so powerful. Questions? Now here comes question 20. Question 20. Are you okay for that? Shall we move on? 寫晒未呢度? Now, one thing I would like to mention with you is the word. Do you know what's mean by what against time? Do you understand this? Do you understand this statement? what is mean by like transmittance of reaction mixture against time? Do you know what does they mean by that? This is this. Can you get a point? 呢句說話嘅意思就係呢個 graph the light transmittance of reaction mixture against time. So what you just mentioned before against, you talk about y-axis, but you want to talk about time against what? That after the word against, it is referring to the data in x-axis. So next time, while you study out of science subjects, right? So you are once you're asked to plot the graph, they will always tell you like this. Okay, could you please put a graph of a speed versus time graph? So what is that? In physics, we call it VT graph. Do you understand? So you are going to do something similar. Y-axis, the name of I-axis come first, and then x-axis. This is our common practice. Now, question 20. Now we have got another experiment on the investigated rate to a certain brand of fizzy drink tablet. When reaction with acid merges, right, with rate of reaction, dissolve in water at 25 degrees. Carbon dioxide is formed from the reaction from the experiment. The setup shown below was this. Explain why effervescence occurs when the fizzy drink tablet is added water, right on the equation. Oh God, what is that? You go back to exit, right? A long story to tell. Do you still remember? What is it about? Do you still remember that? A part, the principle. While you put a fizzy tablet, put it into the water, they will cause effervescence. The reason?
Because like the hydrogen ions react with the sodium hydrogen carbonate to give carbon dioxide gas.
So you jump to the last part. It's the sodium hydrogen carbonate react with hydrogen ion to form carbon dioxide and water, right? So this is the solid form. So in case you want to tell the hydrogen carbonate also dissolve with water, you may simply skip the spectator ion and write down AQ, okay, like this. So this is the Ionic equation. You just mentioned this. How about the explanation part? We have got hydrogen ions, right? The hydrogen ions react with sodium hydrogen carbonate to give carbon dioxide. Now this is what I heard from Zhang. So this is the carbon dioxide gas. You mentioned a gas, so that's why there is effervescence. Now you just mentioned this, right? So, but the question comes, how comes there is hydrogen ions? Hydrogen ions originally come from the tablet. Is it? We've got hydrogen ions inside the fizzy tablet. 有冇㗎？黃正濤有㗎，係咪入邊有 hydrogen ion 㗎 ？The fizzy tablet. Do we have it?
Yes.
Yes, hydrogen ion. How will it be already inside, right? Inside tablet. So what does it contain with the fizzy drink tablet? Now I show it is a solid acid and solid sodium hydrogen carbonate. So usually the solid acid is citric acid. So that's why on the market you would be quite common to find the frizzy tablet being orange or lemon flavor. Have you ever thought of having a frizzy drink tablet which is made up of different flavor? 有冇諗過啊？ why don't they make the fizzy tablet with strawberry? Do you know why? Because the solid acid, it is the citric acid. While the citric acid is dissolved in water, you smell it, it seems like citrus fruit. You know what is meant by citrus fruit? 骨子嘅骨子類嘅植物啦嘅生果啊。So citrus fruit in mainly you cover it as orange or lemon. Can you get my point? So that's why it's a convenience, it's a promotion. They will tell the frizzy tablet, fizzy drink tablet, having a flavor of orange or lemon. It's simply because I add citric acid inside. But you go back to our first question, citric acid solid, it doesn't contain hydrogen ions. How can we have hydrogen ions? You know that solid acid is just hydrogen atom, or not hydrogen ion. Go back to what you know in acid and alkaline, that chapter.
Dissolve in water.
Yep, once it does dissolve water, what will happen? What will happen to the solid? The acid, you use one technical term, I need to heard about this term. Anyone who can try?
Ionizes.
Yes, ionizes, right? So this is the key point. Ionizes to give hydrogen ion. So that's why I have got hydrogen ion to react with sodium hydrogen carbonate, or in particular hydrogen carbonate ion. Now both are okay. Do you understand? So go back to Hayes' answer. He indeed mentioned what is happening during the observation, but my explanation should start from the very beginning. What is the content, the chemical content found inside the frizzy tablet, and then tell me what happens when I add into water. Can you get the point? Such as to give the references, just like 學是學非, right? So you are going to go back to the very beginning and tell me the answer. Do you understand? Now, by doing so, would you make the questions complete? The mass of the sodium hydrocarbonate in one fizzy tablet was 1.25 grams. What is the mass of carbon dioxide given off? What is the mass that can be given off? So it comes from one assumption. The assumption is more all hydrogen carbonate would be reacted. Otherwise, we cannot do such or reacted. So this is the assumption of this calculations. Do you understand? So according to the equations, the number of moles of what the carbon dioxide to be formed, it is just come all from sodium hydrogen carbonate. So I start from this. Sodium hydrogen carbonate, it is calculated as what? Mass. Do you still remember the molar mass of sodium hydrogen carbonate? So you may get it as 1.25 gram, 84.0 gram per mole. So what we will get it is 0.0149 mole. So you use this to project the mass of CO2 formed. So of course, what you just mentioned is just the maximum mass of CO2 formed, which is calculated by 0.0149. This is number of moles. I don't want that mole, but I want the mass. So you times the molar mass of CO2. So 0.0149 mole times, what is the molar mass of carbon dioxide? What is the molar mass of carbon dioxide?
44.0.
Yep, 44.0 gram per mole. So you may get the answer. The answer is 0.656 gram. But of course, in this question, they ask for mass only. But in practical sense, we besides you mention the mass, you can also measure the volume, right? So you may find the mass first over here, the mass of it will drop it at 0.5656. Okay, you get my over time. So just one advantage of using data logger in this experiment. Don't mention it again. You should know the answer, right? You can get a continuous data, and somebody, you may also think of the change in mass. The change in mass over time is very small. So the use of data, they will give more accurate results. Okay, besides using merely a electronic balance. Questions? Any questions so far? Now, finally, we come to question 21. The kinetics in the fast reaction shown below the investigated series of reaction outline titrametric method. A is alkaline, B, C, D are neutral. So mention is alkaline. So the major 3 steps, so you are going to mention to measure the change in concentration. First of all, take the samples. Give me that. Small known volume at regular Number 2, you are going to use one keyword. What is that? Before you do titration. Do you still remember?記唔記得？點寫啊？呢一隻個 verb 係咩㗎？用咩方法 ？I want to rapidly stop the reaction. So you should have a technical term. What is that? 唔記得咗啦，有啊。What is the keyword?
Cooling effect.
Cooling effect. Cooling 係啦，咁但係前面嗰個字先唔係 cooling。字點啊
？Q 字頭。
係啊。咩㗎？
一個記得但係唔知點寫嗰個
U N C H quench Quench.
Quench.
You quench the reaction by pouring the solution mixture into large amounts of ice or water. Do you still remember what are the two principles? One, dilution. Two, cooling. They will slow down the reaction. Do you still remember? Dilution and cooling, they will both slow down the reaction, the rate of reaction. So you are going to finally titrate each sample against a standard what? Now A is alkaline, so you use a standard exit. Okay? Do you still remember the standard exit? Now I do hope by covering all those, you will know something more about the questions about the rate of reactions. Now, next lesson, we come to the start of a new chapter. Okay, so I would like to see you guys in the supplementary lesson. We will resume that because we will miss very soon. So can I have the lesson tomorrow afternoon? Okay, we will try to continue. And before you go, let me know your understanding today. Now we come to long question today. Anything that you want to ask? Anything that you don't know? How's your understanding? Let me know now. Double check the attendance from all of you. All right. Okay. So, hey, from 0 to 10, or maybe you should be busy about your copying the answer, right? Now 5, 6, 7, take a look. Colorimetry, graph part. So colorimetry. Okay, maybe tomorrow I would like to talk something more about that. Colorimetry, graph part. 嗰個叫校準圖表啊，即係話我哋去係啦，咁咧我哋就聽日會講啊嚇，得唔得？咁啊 break 咗先，好冇？你跟住就 formula of exchange chemical， 我見多啲就得㗎啦，呢個就 OK。嗱，你上網睇翻嗰個calorimetry， 跟住 calibration curve 咧，你要睇多少少呢個資料先啦，同學。咁我聽日俾少少時間你再問，好冇？我大概知道大家有啲咩唔明啦。Okay, I would like to stop it here. Okay, let's have a break. Goodbye. Bye bye.
Bye bye. Bye bye.
Bye bye.
Bye guys.
Bye bye.
Bye.
係。
講話前述。